Hello. Today we're going to be talking about standing waves, also known as stationary waves. We'll start by reminding you what a progressive wave is, and then contrasting it with the standing wave. Then we'll talk about some of the features of the standing wave, such as nodes and antinodes. And finally, we'll explain how the standing wave is formed. Okay, so in the past when we've talked about waves as transferring energy from one place to another. So the wave transfers energy from A to B. However, this is only one type of wave known as the progressive wave. The other type of wave is known as a standing wave. Standing waves do not transfer energy from one place. Standing waves are shown in the GIFs above. As you can see, the endpoints for a standing wave always have a fixed displacement. That is, they do not move. Hence, no energy is transferred but from one end of the standing wave to the other. On the right-hand side now, we have a progressive wave. As you can see, in the progressive wave, every point reaches the maximum displacement. Every point in the progressive wave, therefore, has the same amplitude. If we contrast this with the standing wave on the left, different points along the standing wave will have different amplitudes. Some of them will have zero displacement at all times, whereas some of them will reach a maximum displacement. Here's a question for you to have a go at yourselves. Pause the video and write down the differences in the amplitude in a progressive wave and a stationary or standing wave, and then do the same thing for energy transfer. I'll give you some time and then I'll give you the answers. And here are the answers. For the progressive wave, every point along that wave has the same amplitude. That is, every point in a progressive wave has the same maximum displacement. However, for a stationary or standing wave, that will vary across the wave. For energy transfer, a progressive wave will transfer energy from A to B through space. However, a stationary wave or a standing wave will not transfer energy. Next up, we're going to introduce some vocabulary to describe the standing wave. As you can see on the right, there are two diagrams showing standing waves. Some points along the standing wave have a fixed displacement, that is, they do not move. We call these points the nodes. In between the nodes are points that have maximum displacement or have the greatest amplitude, and we call these points the antinodes. The diagram on the left shows a standing wave where the point W is moving down. This implies that points X and Y will move upwards and points Z will move downwards. That's because points X and Y are between the same node, and so therefore we say they are in phase with each other. They're moving in the same direction. Conversely, as points X and Z are on opposite sides of a node, we say they are out of phase with each other. That is, as point X moves upwards, point Z will move downwards. We can contrast this again with a progressive wave. If we choose any two adjacent points on a progressive wave, they will not be in phase with each other. Instead, we say that the points in phase on a progressive wave are 2 pi radians separated from one another. Finally today, we're going to discuss how the standing or stationary wave is formed. If you've never seen a standing wave before, I'd advise you follow one of the video links in the comments. One example of a standing wave which can be seen in the classroom is the standing wave on a string. The wave is formed originally by a vibration generator, which then goes down the string towards the pulley. Once it reaches the pulley, it's then reflected back. However, this reflected wave then superposes or interferes with a new wave formed by the vibration generator. What forms is the standing wave, where we have a sequence of nodes and antinodes along the string. The reason we're forming nodes and antinodes is because of the way the waves are meeting. At the nodes, the waves are always meeting out of phase with each other, whereas at the antinodes, when we have maximum displacement, the waves are meeting in phase with each other. At the nodes, where the waves are meeting out of phase, destructive interference is occurring, creating points of zero displacement. However, at the antinodes, where the waves are meeting in phase, we're getting constructive interference. It's important to note that in order for a standing wave to form, the two overlapped waves should have the same amplitude and frequency. This is obviously going to be the case for a wave and its reflection. Here's an opportunity for you to see how much of what we've done you can recall. Stop the video and write down an answer to the following question. And here are the answers.